Hi guys, welcome back to my channel. Today I'll be covering implicit differentiation. In the last videos you've applied some of the approaches I taught you, you've applied it to different types of function, and you have to know that all the derivative we've been doing, all the function we've been differentiating since this while, they are known as explicit function. We are differentiating explicit function. But today, so I'm going to teach you how you can differentiate an implicit function. Can you tell me the difference between implicit and explicit? As the name imply, when you have explicit function, like I've explained, all the functions we've been doing before they are known as explicit function. That is functions where x could be made difference or could be separated from y easily. For example, if you look at this function, you will see that I have 1 on the other side and I have x on the other side. You understand now? So this is an example of explicit function. But when you have an implicit function, take for example, I have e raised power x s sin y. If you have z to be something of that nature. So this is an example of implicit function. Implicit function. That is, your x and y cannot be separated from each other easily. Don't say they cannot be separated from each other. So mathematically, although it might be difficult to do, but you can do that. So, but that might take time actually. So that's an implicit function. So that's what we are going to do today. But before we go, let me remind you of something. Remember that if I have y is equal to s raised power 3, you know the y ds here is what? 3s squared. There is something we've been missing, or we didn't take notice of it, which is what? You know, this is the y ds, that is, we are differentiating this function. What are we differentiating? You know it is x, right? With respect to what? With respect to x. But because this will give us 1, that's why we don't write it. You understand now? So, but when you now have y raised power 3 and you ask to differentiate it with respect to x, then if I have z is equal to y cube and I'm asked to differentiate with respect to s, then I'm going to have what? What's the derivative of y cube? That will give me 3s squared. What am I differentiating? The y with respect to what? With respect to s. You understand? Now it means the derivative of this will give me what? With respect to s will give me 3y squared the y ds. Please put this at the back of your, and so today let me give you an example that you could use implicit, that is implicit in nature. For example, find the derivatives of s squared plus y squared is equal to 25. S squared plus y squared is equal to 25. It is not difficult at all. Solution. Let me ask you again, is this an implicit function or an explicit function? So with respect to s, sorry. So it is an example of implicit function because s could not be separated from y easily, right? So it is different from what we've been doing before. So solution. It is very simple. You just say differentiate both sides with what? With respect to x, and you take it one by one. Don't forget your linearity property. It means you are going to differentiate this s square. What's the derivative of s square? That is 2s. Don't forget what I told you the other time. Put the s, because what did we differentiated? X with respect to what? With respect to s. Then plus, what is the derivative of y squared? Derivative of y squared will give me what? 2y. Which variable did I differentiate? I differentiated y with respect to what? With respect to x. Then is equal to, what's the derivative of constant? That will give you 0. You don't need to stress yourself. This will give me 1. Then I have 2x plus 2y dy dx is equal to 0. Then you come bring this guy to other side, then I'm going to have minus 2s. If you divide through by 2y, that will give me minus 2s divided by 2y is equal to minus s over y. You can see it is very simple, isn't it? Yeah. Let me give you another example that is more complicated. Number 2, if xy plus sin y is equal to 0, find dy dx. It is very simple as well. Solution: I have xy plus sin y is equal to 0. Okay, let us take it one by one. Don't forget your linearity property first. You say differentiate both sides with respect to s. And trivially, it is an implicit function because s cannot be separated from y easily. Okay, let us take it one by one. You know, this is like a product rule. And don't forget what I explained the other time, that when you have a product rule and you want to solve it, it's just like, okay, for example, if you have UV, it's just like saying differentiate the first, leaving the second as it is, plus differentiating the second, leaving the first as it is. That's why I asked you not to memorize the formula. Okay, let us check this. Okay, xy, you know it is product because it's a function. This is another function on its own. You understand now? So, okay, differentiating the first, the derivative of x is 1, right? But it is x. We are differentiating it with respect to s2. Leave the second as it is, then you have y, then plus differentiating the second. What is the derivative of y? That is 1. But we are differentiating y with respect to s. You have to put the y ds. So leaving the first as it is, that is x. Then plus, what is the derivative of sin y? That will give me cos y, but we are differentiating y with respect to h, with respect to s is equal to 0. Can you see it is very simple? Don't stress yourself. This is 1, then I have y plus s dy dx plus cos y dy dx. So since we are interested in making dy the subject of the formula, you can bring this guy out. Then I'm going to have x dy dx plus cos y dy dx is equal to minus y. Your dy dx is common, then x plus cos y is equal to minus y. Then if you collect the like, if you divide through by s plus cos y, then I'm going to have minus y divided by s plus cos y. You can see it is very simple, isn't it? And lastly, let me give you a more complicated one. It is not difficult as well. Number 3, if x squared plus y squared minus 2s minus 6y plus 5 is equal to 0, find a dy dx, b the squared y dx squared, that is the second order derivative at x is equal to 3 and y equals 2. So at x is equal to 3, y equals to 2. Yeah, they're supposed to give us, dy dx as well. So they're supposed to give dy, but if they don't give it, let me say, and dy dx is 0. Dy dx is 0. Yeah. S is equal to 3, y is equal to 2, and y dx is equal to 0. Okay, yeah, let us proceed. So the first one, I have my s squared. No, sorry, this is not there. Don't worry, this is not there. Because we are going to obtain our dy dx from here. So I have my s squared plus y squared minus 2s minus 6y plus 5 is equal to 0. It is an implicit function. What are you going to do? Differentiate both sides with respect to h, with respect to s. And don't forget the clue I gave to you. Do it one by one. Derivative of s squared is 2s, but we differentiated what? X with respect to x. You have the s, then plus, if you like you may not write it, but to make it clearer, that's why I wrote it. So derivative of y squared will give me what? 2y, but we differentiated y with respect to what? X. Then minus, what is the derivative of 2x? That is 2, but it is x. You don't need it because it is ds, you will not bother to write it. Then minus derivative of 6y will give me 6, the y, the x, plus what is the derivative of a constant? That is 0 is equal to 0. Then since we are interested in collecting the like time, then you can say this guy will go again. Then you have 2x minus 6 plus 2y divided dx minus 6 divided dx is equal to 0. So then you can take this guy, these two guys, you can take them to other sides. Then I have something of this nature. That's my 6 minus 2s, isn't it? So then my dy dx is common. If you factor it out, minus 6, 6 minus 2x. If you make dy the subject of the formula by dividing both sides by what? 2y minus 6, then I'm going to have something of this nature, 6 minus 2x, 2y minus 6. And don't forget 2 is common, I can take it out. This is 3 minus x. 2 is also common here, that's y minus what? Minus 3. Then this guy cancel each other. Then I have dy dx to be what? 3 minus x divided by y minus 3. That is very simple, isn't it? So, but don't forget from the question we were given s, we are asked to find it at point s equal to 3 and y is equal to 2, right? Then you can conclude by saying dy dx at these 2 points, s equal to 3 and y is equal to 2 will be what? That is, wherever you see s, you replace it with 3 and y with 2. Then I'm going to have that dy dx, that's 3 minus what? What is my s here? 3 divided by 2 minus 3. That's going to give rise to 0 because 3 minus 3 is 0 and 0 divided by any number will give me 0. Okay, now let us find the squared y dx squared. Remember, the square y dx squared is your second order derivative. That is, you have to differentiate what you've differentiated before. d dx of dy dx, which is same thing as d dx of, what is my dy dx? That is 3 minus s y minus 3. That is also implicit function. You understand now? But here you are going to use what? Quotient rule. And you must have it at the back of your mind. Is also is an implicit function because you have x and y together in that function. Okay, now let us assume this is what? Call it another thing. I don't want to call it y, let's say w. So okay, now don't forget your quotient rule. Your u is your numerator and your v is the denominator. I don't need to stress myself. Then my d square y dx square will be what? V, that is the denominator. The u ds, derivative of 3 minus s will give me minus 1. But since we are differentiating with respect to s, it is s and we are also differentiating with respect to s. You can write ds or you may not write it. Then minus u, that's 3 minus x. The v ds will give me 1, but since I'm differentiating this with respect to y, then you are going to write the y, the x, then divide by v squared. That will give me y minus 3 everything squared. So if you do it together, then my d square y dx squared will give me minus y minus 3. You understand? Then minus 3 minus x dy dx divided by y minus 3 everything squared. But remember that my dy dx from what I did here is what? We have it to be 0, right? So then if you substitute into this one, then I'm going to have minus, sorry my pen, y minus 3 minus 3 minus x multiplied by 0 since my dy dx is 0, y minus 3 squared. This will give me minus y minus 3 y minus 3 squared, and this guy will cancel one of these, which is the same thing as minus y 1 divided by y minus 3. And don't forget my y. Okay, if you find the derivative, d squared dx squared, here is maybe since dy dx is equal to 0. Dx squared, add the values of s and y, so that will give me minus 1 divided by, what is my y? 2 minus 3. That will give me minus 1 over 5. That's your result. You can see it is very simple. Please, if you've not subscribed to my channel, don't forget to do so and like it. If you enjoyed this video, invite your friend to watch, share and like as well. I will meet you in the next video. Thank you.